All NEET aspirants. So in this episode, we will calculate this number of ATP step by step from simple to complex. Keep your pen and paper ready and calculate along with me. Fix the numbers and concept connecting to it in your mind. You can recall in NEET examination without any complexity. So simple to complex. How many number of ATP formed in glycolysis per one glucose molecule? Per one glucose molecule, one molecule of fructose 1,6-biphosphate cleaved into G3P and DHAP. Again, DHAP isomerase to G3P. So, how many G3P molecules are formed? Two G3P molecules are formed. For every G3P, two ATP are formed. Where it is formed? In one step, 1, 3 biphosphoglyceric acid to 3 phosphoglyceric acid, 1 ATP. And phosphoenol pyruvic acid to pyruvic acid, 1 ATP. For 2G3P, 4 ATP are formed. Next, how many net ATP formed in glycolysis? As total 4 ATP formed. In first and third reaction phosphorylation, third reaction phosphorylation, 2 ATP are invested. So total ATP 4, 2 ATP consumed, invested. So net gain of ATP is going to be 2 ATP. Next, glucose is the substrate. If glucose 6-phosphate is the substrate, how many net ATP formed? If glucose, it has to utilize 1 ATP. As I am saying, glucose 6-phosphate. So net ATP is going to be 3 ATP. And fructose 6-phosphate, the same, net ATP is going to be 3 ATP. Fructose 1,6-biphosphate, fructose 1,6-biphosphate cleaved into 2 trioses is going to give 4 ATP. And we cannot say now fructose 1,6-biphosphate on board, it is a net ATP because no ATP invested. As you are saying, fructose 1,6-biphosphate is the substrate. How many ATP formed? 4 ATP formed. Next, how many net ATP formed in glycolysis with involvement of oxygen? There is no involvement of oxygen. Oxygen is utilized only during oxidation of NADH formed in case of glycolysis. So, per 1 glucose, 2 NADH are formed. Each NADH gives 3 ATP. 2 NADH gives 6 ATP. As earlier we said, net gain of ATP 2. So 6 ATP, 2 ATP. So with involvement of oxygen, net ATP is going to be 8 ATP. Next, how many total ATP formed in glycolysis for 1 glucose with involvement of oxygen? As total ATP 4. 2 NADH2 gives 6 ATP. 6 plus 4, 10 ATP in case of glycolysis with involvement of oxygen per 1 glucose molecule. Next, from pyruvic acid to acetyl coenzyme A, 1 NADH2 per 1 molecule of pyruvic acid. In this Krebs cycle, at 3 points, 3 NADH2, 1 point, 1 FADH2, at 1 point, 1 ATP formed. So, oxidation or oxidative breakdown of pyruvic acid yields how many number of ATP for 1 pyruvic acid? So for 1 pyruvic acid, how many NADH2? 4 NADH2. In link reaction, 1 NADH2. Krebs cycle, 3 NADH2, 4. 4 into 3, 12. 1 FADH2 going to give 2, 14. And 1 ATP in TCA cycle, that is 50. So 12 plus 2 plus 1. 12 from NADH, 2 from FADH, 1 SLP of TCA. So it is 50. So oxidation or oxidative breakdown of 1 pyruvic acid, it is 15 ATP. So remember this 15 ATP for in case of mitochondria. So mitochondria, 1 pyruvic acid, 15 ATP. For 2 pyruvic acid, 30 ATP. Next, the same changed in some other form. Question. How many number of ATP formed due to oxidation of coenzymes for one pyruvic acid in mitochondria? So only coenzymes. So I have to ignore the ATP formed at substrate level phosphorylation in TCA. So how many NADH for one pyruvic acid? 4. 4 into 3, 12. How many FADH2 for one pyruvic acid? 1, 2. So 12 plus 2, 14. We have to ignore SLP in TCA. Next. How many number of ATP formed due to oxidation of one acetyl coenzyme in TCA? In tricarboxylic acid cycle, 3 NADH2, 1 FADH2, 1 ATP. So 3 into 3, 9. 1 FADH2, 2, 11, 1 ATP, it is 12. So 12 ATP due to oxidation or oxidative breakdown of one acetyl coenzyme. Next, just a change. How many number of ATP formed due to oxidation of coenzymes for one turn of Krebs cycle? Again, you have to ignore the ATP in SLP. 3 NADH2, 3 into 3, 9, 1 FADH2, 2, 11. Next. So oxidation of pyruvic acid is going to give 15 ATP. You have to remember that one. You come for this next, that is glycolysis. For 1 PEP is going to give the pyruvic acid and 1 ATP. Oxidation of 1 PEP or oxidative breakdown of 1 PEP in aerobic respiration is going to yield how many number of ATP? As I earlier said, for 1 pyruvic acid in case of mitochondria 15. 1 PEP to 1 pyruvic acid 1 ATP. We have to add this 1 ATP. So 15 plus 1, 16 ATP due to oxidation of 1 PEP. In above step, that is 3 phosphoglyceric acid to 2 phosphoglyceric acid. How many number of ATP formed for one molecule of 3 phosphoglyceric acid? The same number, that is 16 ATP. There is no formation of any ATP at that step. Next. 1, 3 biphosphoglyceric acid is going to give 3 phosphoglyceric acid, that 1 ATP formed. So question is, how many number of ATP formed due to oxidative breakdown of one molecule of 1, 3 biphosphoglyceric acid? So 1, 3 to 3, 1 ATP, PEP to pyruvic acid, 1 ATP, 2 ATP. In earlier we said in case of for 1 pyruvic acid in mitochondria 15. So 15 plus 1, it is 17. Next question. Above 1, 3 biphosphoglyceric acid is G3P. Oxidation or oxidative breakdown of one molecule of G3P or one molecule of 3-PGAL gives how many number of ATP? This you have to remember in case of mitochondria for 1 pyruvic acid 15 ATP. PEP to pyruvic acid 1 ATP 16. 1, 3 to 3 17. 1 G3P is going to give 1 NADH. 1 NADH is going to give 3 ATP. So 17 plus 3, 20 ATP. So oxidation or oxidative breakdown of one molecule of G3P is going to give how many number of ATP? 20 ATP. Another DHAP converted into G3P, that is going to give 20 ATP. So total ATP formed in aerobic respiration for oxidation of one glucose molecule is going to be 40 ATP. So how many net ATP formed in case of aerobic respiration per one glucose molecule? 40 ATP, and 2 ATP consumed in first and third reaction of the glycolysis is going to be 38 ATP. So total ATP 40. Net gain of ATP 38 ATP. Next. How many number of ATP per one glucose formed in mitochondria alone? As we said, for 1 pyruvic acid mitochondria 15 ATP. As you am saying, one glucose molecule. So I have to consider 2 pyruvic acid. 15 plus 15, 30. How many total ATP formed in mitochondria alone? 30 is not the answer. In glycolysis, 2 NADH formed. The 2 NADH enter into mitochondria. On oxidation is going to give 6 ATP. So 30 plus 6 ATP, you have to consider it as 36 ATP formed in mitochondria alone for oxidation of one glucose molecule. Next, how many number of ATP formed by oxidation of all reduced coenzymes for one molecule of glucose? How many NADH formed? 10 NADH. How many FADH formed? 2 FADH. 1 NADH, 3 ATP. 10 NADH, 10 into 3, 30 ATP. 1 FADH to 2 ATP. 2 FADH to 4 ATP. 30 plus 4, 34 ATP. So, number of ATP formed only due to oxidation of coenzymes, 34 ATP. And net gain of ATP formed in aerobic respiration for one glucose, you have to consider 34 ATP, 2 ATP in case of glycolysis, 36, and 2 ATP in 2 cycles of TCA. So, comes under 38 ATP as net gain. 34 only due to oxidation of coenzymes. Next, how many ATP formed due to oxidation of all NAD coenzymes? All NAD coenzymes mean 10 NADH to 10 into 3, 30. How many number of ATP formed NAD coenzyme generated in case of mitochondria only? In mitochondria, for one glucose, how many NADH are generated? 8 NADH are generated. 1 NADH is going to give 3 ATP, 8 NADH is going to give 8 into 3, 24 ATP. Next, how many ATP formed in all substrate level phosphorylation in aerobic respiration per one glucose molecule? In glycolysis, 1, 3 biphosphoglyceric acid to 3 phosphoglyceric acid, 1 ATP. Phosphoenol pyruvic acid to pyruvic acid, 1 ATP. And in case of the Krebs cycle, succinyl coenzyme A to succinic acid, 1 ATP. And we consider it is a glucose. So in glycolysis, 4 ATP. In Krebs cycle, 2 ATP. So total it is 6 ATP. What is the ratio of ATP formed in SLPs of glycolysis and Krebs cycle? In glycolysis 4, Krebs cycle 2. So 2 is to 1, like that. Next, how many CO2 liberated for one glucose in mitochondria? In pyruvic acid acetyl coenzyme, 1 CO2. In case of the Krebs cycle, 2 CO2. As you are saying, 1 glucose, you have to take 2 pyruvic acid. So it comes under 6 CO2. How many CO2 formed per 1 pyruvic acid in Krebs cycle? In Krebs cycle only 2 CO2. In mitochondria it is 3 CO2, like this. So I am signing off from this episode. As you done so far this number of ATP, I hope you are going to be familiarized with all the content of the NCERT up to this. So listen with concentration, listen with attention, connect to the concept, numerals, and at the time of examination it is easy to recall. And if you feel this approach is right, subscribe and share to the person they are seriously preparing for a NEET. We will see in case of the next episode, that is amphibolic pathway.